Hello students, welcome back to the fourth video of this playlist. In this video, we will be solving question number 4 from the most recent past paper of further pure mathematics, which is the May 2024 F1 paper. So let's get started with question number 4 of the paper. Okay, so here the question says the complex number z is defined by z equals to -3 plus 4i. So part A is asking to determine the modulus of z squared -3. Okay, so z squared -3. Let's get the equation for z squared -3. So this is basically -3 plus 4i whole squared -3. Okay, so z squared -3 equals to, let's expand the bracket. So that would be a squared plus twice of ab. So twice of a is -3 times b is 4i plus b squared. So plus 4i whole squared -3. Okay, so z squared -3 equals to 9. 2 times -3, it is basically -6 times 4, it is -24i, and i squared is -1. So -1 times 4 squared, which is 16. So -16 -3. Okay, so z squared -3 equals to 9 minus 16, it is basically -7. So -7 -3, it is -10. So -10 -24i. Now they are asking for the modulus. So modulus of z squared -3, it is equals to square root of -10 whole squared plus -24i whole squared. Okay, so the modulus, okay, the value for the modulus, you will get 10 squared. 10 squared is basically 100, and 24 squared times -1. So that would give you, okay, 24, it's not 24i, because we know that the modulus is basically x component. This is the component along the real axis. This is 10 minus 24i. So basically this is 24 units, and this is 10. So that would be 10 squared, -10 squared. Oh, it's -10 squared. So that would be along the negative real axis, and negative plus 24i. So plus 24 is upward. Okay, so the resultant is this one. So the resultant is square root of -10 whole squared plus only 24 whole squared. Okay, not i. I is basically the direction. Okay, so we will just consider the magnitude, that is 24, the component. Okay, so -24 whole squared. So that would give you 100 plus 676. Okay, 100 plus 24 squared, it is basically 676. So square root of 676, it is 26. So modulus of z squared -3, it is only 26. And that's the answer for part A. Fine. Okay, next is part B. In part B, the question is asking to express 50 over z star in the form k times z, where k is a positive integer. Okay, so 50 over z star. So z star is what? It's basically the conjugate number of the complex number z. Okay, so at first we have to simplify 50 over z star. Okay, so 50 z star is basically the conjugate of z. So that would be -3 -4i. Okay, just it will here it was plus. For conjugate it will be just negative. Okay, so 50 over z star, it is equals to 50 over -3 -4i. Okay, now we have to simplify it. So to simplify this number 50 over z star, we have to multiply the denominator by its conjugate. Okay, so that I gets eliminated. Okay, so negative 3 negative 4i times z, right? It is negative 3 plus 4i. So same goes on the numerator. We have to multiply the numerator by the same z, negative 3 plus 4i. Okay, now we can see that in the denominator we can apply the formula for difference of squares. So we will have negative 3 whole squared, a squared, this is a squared, minus b squared. So minus b squared, b is basically 4i whole squared. Okay, a plus b, this is a minus b times a plus b. Okay, so that's why this is difference of square formula, a plus b times a minus b. Okay, which is a square minus b squared. And in the numerator, 50 times negative 3, it is negative 150. It is negative 150, and then plus 50 times 4, it is basically 200. 200i. If I'm not wrong, it is 50 times 4, it is 200i. Okay, now simplify. 3 square, negative 3 whole square, it is basically 9, and you got negative 4 squared. 4 squared is 16, so negative 16 times I squared is negative 1. Okay, and in the numerator you have negative 150 plus 200i. Okay, so 9 minus 16 times negative 1, so that would give you 25 in the denominator, and in the numerator we have negative 150 plus 200i. Okay, now simplify further. What, negative 150 over 25, it is basically negative 6, plus 200 over 25, it is 8. So negative 6 plus 8i, this is the number 50 over z star. Okay, so we have to represent it in the form of k times z. So z is negative 3 plus 4i, so we have to just take 2 common. If you take 2 common, you will get negative 3 plus 4i. So that means it is 2 times z. So the value for k, it is equals to 2. And that's the answer for part B of question number 4. Fine. Okay, next is part C. In part C, the question is asking, hence find the value of argument of 50 over z star. Give your answer in radians to 3 significant figures. Okay, we have to find out the argument of 50 over z star. Okay, so to understand the argument, we have to consider the we have to understand the complex number 50 over z star on the Argand diagram. Okay, so this is the real axis, this is the imaginary axis, sorry, and this is the real one. Okay, so so 50 over z star for part C, 50 over z star, that was negative 6 plus 8i. So negative 6 plus 8i, it will go to the left and then up plus 8i. So the vertical component, this is basically 8 and this is 6. Okay, so the argument is basically measured from the positive real axis. So this is the argument. So to get the argument, we need to figure out this theta at first. Okay, so let's find out that theta. So tan theta equals to 8 over 6. Tan theta equals to opposite side, that is 8, over the adjacent side, which is 6. So theta is equals to tan inverse 8 over 6. Remember, your calculator should be in radian mode when you calculate the inverse. So that would be 0.92729521.8 radian. Okay, so we got the theta. Therefore, so argument of 50 over z star, it is pi. Pi is what? This is whole is pi, right? So pi minus theta. So pi minus 0.92729521 radian. So that would be 3.1416 minus 0.927 dot 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 something, the value you can see on the screen. So you will get 2.21430.4782 radian. So we can write it to, we have to write it to three significant figures, which is 2.21 radian. This is up to three significant figures. That's it. That's the argument of 50 over z prime z star, which part C has asked to find out. Okay, and that's what we got. And that's the end of question number 4. Fine.